Namaste, I am JVM Dr. Kiran Yadav. Welcome to the digital session of Jayoti Vidyapeeth Women's University. This class is for DET and DET+B.Tech third trimester. The topic that will be covered in today's class is electric dipole and dipole moment. Whenever two charged that are opposite in charge are placed nearby to each other, then such an arrangement is termed as electric dipole. Okay, so here you can see at point A there is a charge minus q, and at point B there is a charge plus q, and these charges are separated by a distance 2a. So this arrangement is known as electric dipole. So the definition that you can write is electric dipole is made up of pair of equal and opposite point charges which are separated by a very small distance. So here the distance is taken equal to 2a because we take the center of this dipole as O. Okay, we join the points A and B through a line, and we take a point at the mid of the line which is O, and both the charges, like the charges at A which is minus q, is at a distance a from this line. Similarly, the charge at B which is plus q is at a distance plus a from this point O. So the total distance between both the charges is taken as 2a. So this is electric dipole, and this midpoint is called the center. This midpoint O is called the center of the dipole, and this line that joins both the charges is known as axial line. Okay, and if we draw a line which is perpendicular to this line, like if I draw such a line, then this line will be called as equatorial line. Okay, so the nature of this electric dipole can be described by a term which is known as dipole moment, and it is denoted by P. This dipole moment basically describes the strength of a particular electric dipole. Okay, so the formula for dipole moment P is the distance between both the dipoles and the amount of charge. So the distance between both the dipole is 2a, and the charge amount of charge is q. We don't take the negative sign here, we just take the amount of charge, so we will only take q here. Okay, so the formula for P is equals to 2aq. The direction of electric dipole is from negative direction to positive direction. So here this is the direction of electric dipole, from negative to positive. Now unit of electric dipole, unit of dipole moment. Here the charge is in coulomb and A is displacement which is in meter. So unit of electric dipole moment will be coulomb meter. We can also write the dimension of electric dipole moment. Dimension of A will be L, because A is displacement and the dimension of displacement is L, and the dimension of charge is AT. So the dimension of electric dipole moment becomes M0 L1 T1 A1. So these are the dimensions. Okay, so where these electric dipoles are found? Okay, this is an important question to be asked. We know there are molecules, different kind of molecules present in the nature. You have studied them as well also. For example, H2O is a molecule. H2O is molecule of water, in which there are 2 hydrogen atom and 1 oxygen atom. Okay, well, in this molecule there are 3 atoms. There are other examples as well where you can find 2 atoms, like NaCl. In NaCl there is 1 atom of Na, sodium, and 1 atom of chlorine. So sodium is positive charge and chlorine is negative charged. If we take the ion form of this, then these both the atoms of Na and Cl are separated by a very small distance. Okay, and when the NaCl atoms form a molecule, these are separated by a very small distance. Okay, and Na is positively charged and Cl is negatively charged. So this can be considered as an electric dipole. Okay. So these molecules are also known as polar molecules. Molecules having an electric dipole moment are known as polar molecules, and there is particular value of dipole moment for such molecules. Even water is a polar molecule. It also has a dipole moment. Another example is HCl. Okay. Well, there are some other molecules also in which the center of positive charge and the center of negative charge are at same place. Means there is no separation between them. That means they does not form any electric dipole. Okay. These molecules are called as non-polar molecules. So these are the definitions of polar molecules and non-polar molecules. And I hope it is clear to you. So when non-polar molecules are kept in an external electric field, then sometimes the center of their positive charge and negative charge displaces, and by this displacement there is a finite separation between the positive and negative charge. Okay, and due to this separation, now there is an electric dipole formed in the system. Okay, so such type of dipole are known as induced electric dipole, because in the molecules there was no dipole earlier. When we applied external electric field, the positive and negative charge present in the molecule got displaced and a dipole is formed. Therefore this is known as induced electric dipole. Now there is one question, which is the distance between Na plus and Cl minus ions in NaCl is 1.28 angstrom. Calculate the electric dipole moment of the molecule. Okay, so here the value of Q is this, and distance 2a is given as 1.28 angstrom. When we convert angstrom into meters, then we will have to multiply it by 10 is to power minus 10. So the formula for P is equals to Q into 2a. So we multiply both the Q and 2a, and we put the value of the dipole moment, which is written here. So this is the answer. So this was an introduction about electric dipole and electric dipole moment. If you have any doubts, please mention in the comment section. Thank you.